Now at this point it might just seem like, well yeah, that's just kind of like a clever way of being able to structure code. And yeah, that's kind of true, that's a fair point. However, the beauty of this is that code which is calling the superclass method, because don't forget it's calling that method on something which is of type of the superclass type, this code can happily and blindly call the greet method and it will always work, because it just relies implicitly on the fact that the subclass knows how to do its own thing as far as the greet method goes. This means that we can code just in terms of the superclass, in terms of the superclass type, but actually invoke code which is defined in the subclasses without having to know what that code does or how it does it. So suppose, for example, we had a list of dogs. We haven't covered collections yet, but to create a collection like a list, you can just do something like this. You can say list of dog, just import this from java.util, dogs equals new linked list. We'll cover this in the collection section, but this is how you create a list of dogs. A list is basically a group of objects, and that group of objects have the same type, or at least are derived from the same type. In other words, they extend the same type. So in this case, we're saying I've got a list of objects where the type of those objects are dogs. This means that I could do dogs.add Daisy, for example, dogs.add Einstein, to be able to add some dogs to a list. And then what I could do is I could say for each dog, this is how you do this as well, to loop through items in a collection, which we'll see again in the collection section. I could say for each dog, just do dog.greet. Now the point is, I don't need to know with any conditionals or if else's or whatever. I'm not saying if it's a friendly dog, do this, if it's an angry dog, do that. I don't need to do that here. All I need to do is call the greet method, and then dynamically at runtime, the correct implementation is going to be invoked within the JVM. So if you just imagine this was a much larger program, and I appreciate this is very difficult to do now because this is a beginner's course, we're just getting started, but just imagine that somehow these two chunks of code are in completely different areas of the program. So imagine this is somewhere in a different class far away, and this is also in a different class. Maybe even it's developed by a different programmer. So the programmer who's responsible for this bit, for calling dog.greet, doesn't have any real communication with the programmer who's responsible for actually creating the list of dogs, for example. Imagine this chunk of code, and this chunk of code, it just basically takes whatever list is given to it, and it just calls the greet method on each dog. This means that if I created a new type of dog, okay, so, I don't know, yappy dog, for example. Maybe all yappy dogs are friendly dogs, so we extend friendly dog, just to show that you can also inherit more than once. Put a constructor in here, public void, greet, and maybe the greet method of this yappy dog, maybe it actually does the same thing, first of all, that a friendly dog would do. So here, we're defining the greet method, but we're saying, do you know what? Do what the superclass does. So if I click here now, this is going to execute this, lick, lick, and bark. Let's jump back down to our subclass. And in addition as well, maybe it goes yap, yap. It does this, for example. Whatever, it's not so important. But what is important is that we go back to app, and if we were to do dogs.add, we could even just create this inline here. Valentina, for example, a yappy dog. You recall we don't actually have to necessarily pull these out into the run references. We're not going to use it anywhere else. I'll try and invoke methods on it in this class, so it's fine. So we can just add it directly like this inline. But this means now that this code will still work. It'll still work. We didn't have to modify this code. We didn't have to change it. We didn't have to write any conditional logic to say, do you know what? Now take into account yappy dogs too, in addition to angry dogs and friendly dogs. We had to do nothing whatsoever to this method. And yet still, when we come to run it, so right click, run app.men, it's fine. We've got Valentino at the end, barking and yapping away, and we didn't have to do anything more. And this is really the power of polymorphism. So what polymorphism is then, is the ability for an object to respond in different ways to the same message. So here we can see we've got the same message. So we're having the greet message. It's the exact same message, or the same method which has been invoked rather, which is probably a better way of thinking about it, to bring it back to this method invocation style of vocabulary and a little less OR. It's the exact same method which has been invoked each time, but because it's been invoked on the superclass type, but at runtime we have instances of different types, the subtypes, which have been added to this list, then we're still getting the correct implementation which has been invoked. And that's what polymorphism is. Poly meaning many, and morph meaning forms. So it's effectively a way of something of the dog type to be able to act in different ways at runtime. And it does this through this mechanism of having a superclass method defined on the superclass, and then having different subtypes which provide an implementation of that. So the subtypes implement it differently, and then at runtime, the correct implementation is the one that's invoked.